Hi everyone, a very good evening. This is Supriya Raman. I work as VP Lead Data Scientist for JP Morgan Chase. I lead the data team for KYC and client onboarding. Today I am here to bring you a brief introduction on NLP, also known as natural language processing. As the word suggests, it is natural language, that's our human generated languages, and that's why it is not as formatted or as readable as a text should be. Therefore, in order to derive the insights out of insights out of this natural language, you need better tools. Talking specifically about the social media, you can collect the data in different formats. It can be audio, video, sounds, but major chunk of it is always text. These texts, as we said, are unformatted, and they are also huge. They are bulky data, and they are also growing exponentially, and that's why you need technologies like big data or cloud in order to have a better storage or better processing of these. But when it comes to deriving insights out of this data, you need tool, and that tool is NLP. NLP refers to data science and machine learning branch. It is concerned with giving computer the ability to understand text and the spoken words in much the same way as a human can do. Before we step forward, I would like to take you through a brief journey of how the communication of humans to the machine has changed over few years. The first picture actually shows the punching machine. You used to have two different machines. The one machine which used to punch the information on the punch card, and then you used to have a punch card readers. These were huge machines. The card which you used to have were bulky. There were limited amount of information which you can punch on each of these cards, and also this was a very time consuming process. Later in 80s you have machines like mainframe and AS400. This might sound very legacy in today's era, but trust me, these are still very relevant, specifically in banking and finance domain. You can have interfaces where you have internet banking or phone banking, which are now built with modern technology, but the core banking of most of the banks now also sits on mainframe. In today's era, the way we communicate with business, or the way we do the first hand systematic interaction with the customers, are always chatbot. Before an operator can reach a customer, most of the business want that you should have a systematic methods by which we can interact with it, and the chatbots are provided on most of the platforms. The last picture here are actually the talking machines which almost all houses have. We have Google and Alexa and Siri in almost all houses. These deal with text again. We have text processing, but in the speech format. We will talk a few areas of application in the areas of NLP. To start with, we have social media analytics. Now, most of the industry, they want to know what the customer is saying about their product. Going by the examples again, if you know Bollywood and if you are a big fan of Rohit Shetty, in whenever he launches his movie, in his interview he says that he want to collect the first hand expression of his customer, and that's why he goes to the movie hall himself, because he want to see on each of his scenes how the customer are expressing their emotions. Okay, and not all of us are well versed as he is, and thanks to NLP and thanks to social media, we have better way to derive this analytics. Talking about the banking and finance again going by example, suppose you are filling up a loan application in a bank. Most of the information which we need from a customer are collected in all the relevant fields. Still, bank provided text field where they want the customers to enter the text while they want to collect this loan. These free texts are actually collected in order to generate the sentiments, and bank actually want to understand the real sentiments behind getting this application from the customer. Automatic summarization plays a very vital role in this growing digital media era, and where we have ever growing publications going on. There are huge documents. We understand we don't have time to go through these, and therefore we need automatic summarization techniques. There are different type of algos which we use. You have abstractive summarization, you have extractive summarization, where basically all these algos, they try to put your document into very concise form so that the gist can be derived in a more meaningful manner. We talked about the speech to text. through the speaking machines. Also, even in Google, right? It is very seldom that we type through Google and then we ask for the recommendation. Many a time we just say, Google, can you help? And then Google can translate the speech which we have given to the text format and provide us the recommendation. The picture here talks about the image captioning. Image captioning is not a pure NLP problem. Here the deep learning pitch in. Basically talking about this problem, the task of the image captioning can be divided into two modules logically. One is an image based model which extract the features and the nuances out of the image, and the other is a language based model which translate the features and the object given by our image based model to a natural sentences. As you can see, the picture is first, the word has been captioned onto it. Using this word, it generates different sentences, and then it also provides the rank to these sentences in order to make sure that the most relevant sentence is actually used in order to caption the image. Chatbot, as the name suggests, is a machine which chats with you. The trick here is to make it as human-like as it is possible. Earlier, the chatbots are mainly, machine learning techniques which were mainly based on pattern matching. But these days, they are more supplemented with natural language processing and also the deep learning technologies. Sentiment analysis here again talks about very similar to what we talked in social media analytics. It combines the natural language processing and the machine learning techniques in order to assign the weighted sentiment score to the entities, topics, themes, and categories within the sentence or the phrases. Here we want to detect polarity. It can be as simple as saying positive sentiments or the negative sentiments, or you can make it more granular, where you can say very positive or neutral, negative, very negative, and so on. Now, when we try to understand the text at a broader level, we can divide the whole process into three different steps. The first step is always about lexical processing, where you want to understand the text itself in the raw form. So that's why the raw text is first tokenized. It is broken into small fragments. Out of these small fragments, we actually want to derive the meaning of each keywords and understand the text. The best example of lexical processing can be your email detection, where you want to classify an email as a spam or a ham. It is solely depend on the keywords which is present in the email, right? Once you understand the text properly, the next phase of it is about understanding the language, and then the syntactic processing came into picture. Here we talk about parsing and the part of speech. The part of speech of each of the words start playing a major significance because you are actually trying to understand the language of the sentence. And that's why different words, like for example, you say can be a verb, it can even be a noun depending on what part of which sentence it has been used for, right? And also there can be sentences which have exactly the same words but they can mean differently. For example, say Ram thanked Shyam and Shyam thanked Ram. These two sentences has actually the same keywords, but they have different meaning because we have difference in what is a subject, what is the object, and what is a predicate in a sentence. And that's why when you try to understand languages, pause, part of speech, subject of the language, subject and the predicate of the sentences start playing a vital role. The last step here is about the semantic processing, where you try to understand the meaning of the sentence. When you're trying to understand the meaning of the sentence, you try to supplement it with the extra informations like general knowledge, domain knowledge, and discourse context. Now, going by example again, suppose I tell a word cat. As a human, as soon as I tell you cat, just the word cat, you can imagine an animal with two eyes and one tail because you have a predefined context to it. A similar kind of context also need to be provided to the models, and that's why suppose we talk about general knowledge. Suppose you have a big document and the word PM and Prime Minister has been used. As a human, we understand both of them actually mean the same, but when you're putting a model, the model should be also supplemented with similar kind of knowledge. Domain knowledge plays very vital role, specifically in domains like healthcare or where you have specific terminologies which need to have additional information other than the text which has been supplied. Discourse context, where different word can have different meaning. For example, you say word bank. The word bank can even be a financial institutions. It can even refer to a river bank, depending on what part of the sentence, how it has been used, right? Now, after these three steps, we talked about the application, which you already talked about in previous slides. Also, on the right side of the slide, you can see we have a context of shallow and a deeper. So, when we say shallow, we actually, when you start processing the text, right, you start with text and the speech and the phonics and so on, and you end up understanding it discourse or semantics or syntax and so on. So, you have context of shallow and a deeper in text. This is the best example of semantics, where if you don't supplement the information in addition to your actual context, you might end up understanding it very differently. Now, this slide actually talks about how deep learning has stepped into NLP. Most of the NLP models which we have now is not solely based on the traditional way as how we have discussed. The semantic processing specifically are being done by deep learning architectures. These deep learning architectures are mainly pre-trained NLP models, which are either based on encoder decoder model or a transformer model. They are deep learning models which are trained on large data set in order to perform NLP tasks. Either you can use as is, or you can use transfer learnings to customize this model to a given task. If it allows you to achieve same or even better performance much faster and in with a very less labeled data. To give you some examples of these pre-trained models, we have here some examples. So the most common of it is actually Google BERT. Google BERT is a very heavy model, and that's why later Google also came up with a lighter version of BERT, which are Distal BERT or Albert. You have model as Robota A, which has been trained on book corpus, and then you have XLNet models, which are bidirectional transformer with permutation based modeling. Now, talking about text encoding, when you talk about text, you cannot directly feed the text into machine because machine only understand numbers, and therefore you need encoding standards. The most primitive method, or the first way of text encoding was ASCII, which was introduced in 1970s when personal computers started. ASCII was the first encoding method, as I said, but it is more popular when you just want to encode English characters. The major limitation with ASCII is it only uses 256 bits encoding, and therefore it can accommodate most of the English characters and some European characters. And later, the Unicode character, we have UTF-8 and UTF-16, which became more prevalent because they have better bytes to represent and they can represent more text other than their English language also. Other common thing which is common in NLP is about corpus. When you say corpus, you just mean huge amount of data in an annotated form. These huge amount of data is actually used in order to pre-train the models. If you talk about NLTK library, which is the most basic library of NLP, it has been trained on Wall Street Journal corpus, which is a pen tree bank corpus. And then you can have different many other corpus also, which has been used by different type of models and different type of libraries. Regular expression is the most basic way of solving the NLP. It is based on pattern. Now suppose you have to, again going by example, if you have to process a huge amount of text and all you want to derive out of this text is a phone number, you understand the phone number of a person will always be a 10 digit, and each of these digits will be digits, right? It will be 0 to 9. So you can derive it using a pattern. Those pattern can be defined. And similarly, if you talk about Aadhaar card or SSN number, even the hashtags which you have, the Twitter hashtags, you can define as long as you can express any of these with help of a pattern, you can define it the regular expressions. This site talks about Zipf's law. It has been given by George Zipf in 19th century. It actually talks about significance, word significance. It talks about if you if you take what George Zipf said actually, that if you take a document of considerable size, which is not very small or very large in size, and you calculate the frequency of the words, right? Frequency actually means how many times that word has occurring into that text, and then depending on the frequency, whichever has the highest frequency, you give the rank to 1. So in this case, you can see that the word the has the highest frequency, so it will get a rank 1. And then you plot it in a graph. Okay, so if you plot in a graph where you have frequency of word on the y-axis and word rank on the x-axis, and you plot a graph, you will get a skewed graph like this, right, where you can see that most of the words have very high frequencies. These high frequency words are also called as stop words, while there will be also words which are rarely occurring in a document. Now again, going by example, suppose you are reading a biography on Sachin Tendulkar. In that biography might be the word Kenya came once or twice. These are rare. This is the example of rarely occurring words which has very less frequency, and that's why it might not be very significant when you want to understand that text as is. What we have to be more concerned about is the significant word. So if you define a cutoff with an upper cutoff and a lower cutoff, and you break it into so everything which comes above the upper cutoff is actually your high frequency word or the stop word, which actually has to be removed. And again, which are have a lower frequency than the lower cutoff, are the rarely occurring word, which can again be shut off. What we are more concerned about is the significant words here, which actually is required in order to build a model. Now, tokenization, as we said, that before you start processing your text, you want to split the text into small elements. These elements can be character, or it can be word, it can be sentences and paragraph, depending on what you want to derive, what kind of meaning you want to derive. As a picture here says, it has taken a sentence and it has tokenized it into different words. Again, going by the NLTK library, you have different type of tokenizer which is available. You have word tokenizer, which breaks the whole text into words. You have also sentence tokenizer. You have Twitter tokenizer, which are very it are very effective when you want to derive emojis or hashtags out of it. And also you have regular expression tokenizer. As we said, if you have a huge amount of text, right, and suppose you just want to derive SSN number out of it. So you can define a regular expression. You need not go through each of word. It will save you time, and you can derive those SSN numbers quickly out of it. Bag of word is something we need to understand in order to understand the vector representation of the word. So in order to understand a bag of words, suppose we take 3 documents, and assuming that each of these documents has only one sentences, the way we create bag of word, this is the most basic way of creating a bag of word, is to generate a matrix. In this matrix, we will have each of these rows which will represent our document. We will shade away all the stop words. We will cut off all the stop words. We will only keep the words which are significant for us, and each of these words will create a column in our matrix, and then we will represent it. So suppose you take the first document, it talks about there is no word actor, and that's why it's marked as 0. The word great occurs, that's why it's marked as 1, and so on. Now this is the most generic way of generating the bag of word. What we want to achieve out of creating a bag of word is basically the vector representation of word, which is actually the projection of word in the continuous vector space. You have word2vec or globe or TF-IDF or even the pre-trained models of deep learning, which we talked about, in order to generate the better vector representation of the words. Again, when you are doing processing on text, you want to shade off all the irrelevant informations. For that matter, we have 2 methods, which is stemming and lemmatization, which is used in order to reduce the redundant token. Here, going by the example, if you see, we have different form of the same words. You have word warm, but it can have different grammatical form, like you have warm, warmer, warming, and warmed, and so on. All of these actually mean the same, and that's why it's not relevant that you process all of these separately. You can just reduce it in its base form and process it. Only the base form can be processed, used for processing. The base form here is known as stem. Talking specifically about stemming, it works on a rule-based engine. This is some of the rule which is mentioned here. You have different formats of stemming. You have potter stemmer and snowball stemmer. But in all these, the gist is that it works on the suffix of the word. That's why every word, you take the word and based on the rule, it shade out the suffix and try to create a base word out of it. But when it does that, many a time the base word which is created, the stem which is created, are not meaningful. For example, if you see here, the word TIES has been reduced to TI, which should be specifically TIE. Therefore, the stem which has been derived is not always meaningful, and we have a different method which is called lemmatization. It is again a pre-processing step. It is used in order to remove the redundant tokens. But in this case, in order to reduce the redundant token, it do a dictionary search. So you can have different variants of the root word again. But in order to derive the root word, which in this case is called lemma, you use dictionary lookups. And because it uses dictionary lookup for each of the word, it is little bit more slower than the stemming. So depending on the context, we have pros and cons of both of these. As we said, stemming not always remove, the stem will not always be meaningful. In case of lemmatization, the root word is always the actual word which you want to derive, but it is a slower processing as compared to stemming. Finally, I want to talk about why NLP is hard. When I say why NLP is hard, it doesn't mean that uh, it simply means that you need to have you have to have extra considerate while you are implementing it. Some of these things which you have to do extra consideration when you are processing the text are as following. The first here is about the ambiguity. So different word, as I said, can have different meaning depending on to the part of speech. Also, it can have different meaning in the same part of speech also. For example, we talked about the word bank. Here it is about duck, and so on. Complex languages, we talked about tokenization, right? So in English language you can tokenize the text, but there are languages where the tokenization is not as simple as we have in English language, and it requires extra consideration when you are processing such kind of languages. Unknown representation are representation where you want to supplement your text with more informations, which can be general informations or domain specific informations, which is required in order to supplement the actual meaning of that text. Expression, now if you see this picture, both of these words, both of these sentences actually mean the same, but they don't have the exact keywords. But as a human we understand that they actually mean the same, but how can you make your machine or can you make your model also do the same to understand it in the same fashion? The fifth thing here is about unmodeled variable. It is about, if you talk about two animals, uh, rat and an elephant. As a human, we understand that rat is a smaller animal, and by automatically it comes to our picture that it is a smaller animal and elephant is a huge animal. We have to make the model also understand that, and it requires extra supplementing. And lastly, it is about the sparsity. When we say sparsity, we understand that when we deal with language, huge huge amount of text which is present are actually stop words which needs to be shed off. We only want to process the significant word, and therefore we need extra pre-processing steps in order to derive the significant words. With that, we come to the end of this topic. Thank you for being an patient listener. All the best.